Hello and welcome to the video. Today we are going to look at another Math Olympiad problem. So we have to find the number of zeros in 2025 factorial. So this is a very large number and we have to find the number of zeros in that. This is also one of the concepts based on Legendre's method or formula. Let's get into it. Okay. So since we have to calculate the number of zeros in 2025 factorial, let's first write down briefly how a 2025 factorial will look like. So it is essentially 1 multiplied by 2 multiplied by 3 4 multiplied by 2025. Okay, now if we look at it, what number generally gives us a 0? They could be, all the 10 multiple of tens, hundreds, thousands, correct? In addition to this, anything which has a 5 and a 2 will give us a 10, correct? Now, if you think about this, all these tens, they have a 5, hundreds, they also have a 5 as a factor, 1000 also has a 5 as a factor. So if there is a way to count the number of 5s and 2s in this whole multiplication, then we will be able to find the number of 10 or the number of zeros, correct? So if we think this 2 and this 5 will give us 110. Similarly, if we write a little bit more, it will be 6 into 7 into 8 into 9 into 10. So the next 5 we are getting is going to be here in 10. But if we look at 2, we have a 2 here, 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 we have 2 here. So there are many 2s. So this whole thing eventually will look like this 2025 essentially will become, if we break it into its prime factors, 2 is a prime, so it will have some power, multiplied by 5, it will have some other power, likely smaller than 2, then it will have some other p1 prime, p2 prime, ... which will have their own powers. But we are not concerned about anything else. We are concerned about 2 and 5. And we know that A, because A is every even term will give us A, and 4 will give us 2 2s, 8 will give us 3 2s. So we have a lot many 2s than 5. Here we have 5 only here, then we will have it here, then we'll have it in 15, then we will have it in 20. So there are far less number of 5s available than the number of 2s available, correct? So if we are able to get this power here B, A is certainly more than B. And if 5 multiplies, we can give it B 2s, and then we will have B as the number of zeros, right? So 5 multiplied by 2, it will have, let's say if B is 2, then A will be something more than 2, but at least we can give 2 2s to it. So there will be some power remaining on top of 2, but you will still have 2 tens if b is 2, right? So at least you will have 2 zeros. So similarly, we have to express this in terms of this. Now how do we find b? So there are, if you, let's say if it is a 10 factorial, then how many fives will be there? 2 fives. Why? Because if we divide 10 for 10 factorial, there will be 2 fives. One will be here 5 and the other will be in 10. So why we are getting 2 fives, and how do we easily know it? If we divide 10 by 5, we get 2 as an answer. So that means we can divide 10 2 times if we divide it by 5. Okay. Now let me erase this because this is out of context. Now if we look at 2025 and we divide it by 5, so we will get 405 multiples of 5. Okay, so is that our answer? Not yet. Okay, so there are 405 sections of 5 we can divide, right? So 5 goes in here, 5 goes in here, then there will be 15, then there will be 20, then there will be 25. Oh, so 25 is giving us one more 5. Then 50 is again will give us 2 5s because 50 is divisible by 25. 75 will also give us 2 5s. So 1 5 we have already counted by this. So these many 5s, multiples of 5s will be there if in 2025 factorial. The other is going to be 2025 divided by 25, which will come out to be 25 times 8 is 200, and then 25 is 1. So these many multiples of 25 inside 2025. Okay. Then is there another number where we can get 3 multiples of 5, which is 125? Okay, we do have. So let's divide 2025 by 125. So if we do some calculation here, so it doesn't completely divide, and then it basically has somewhat remainder. But what we are absolutely sure is there are at least 16 multiples which lie within the 2025 numbers, which will be divisible by 125. So there are about 16 multiples of 125. Then is there a fourth power of 5? Yes, there is a 2025 divided by 625. Okay, so let's do that here. So essentially there are 3 multiples of 625. Is there a fifth power of 5? So this is 5 to the power 1. This is 5 to the power 2. This is 5 to the power 3. And this is 5 to the power 4. So if we multiply 625 by 5, it will be over 3000. Correct? 6 into 5 is 30, and then it will become more than 3000. So it will not lie. 5 to the 5 days is not a is not something that we will see. Okay, so we got 4 numbers here, 405, 81, 16 and 3. So if we add all of these up, 405, 81, 16 and 3. So 6, 6, 12, 3, 15, 105. So 505. These many zeros will be there in 2025 factorial. Okay. Now, earlier I mentioned that it's also a Legendre's formula. So what it tells us is, let me erase this. Legendre's formula is to find the power of a prime factor, let's say it is P, in a factorial of n, the sum will be n by P, k is equal to 1 to infinity. So what this means is, so this is called floor function. So it will tell us what is the integer part of it. So this is called floor function. So we are dividing n from n factorial. So here we have n factorial. We have to divide this n by the same prime number p, and then we have to start increasing the k from 1 to as high as possible. Now, so you think of it as 2025 here. So we are actually doing a 2025 by 5 to the power 1 plus 2025 divided by 5 square plus, so floor functions of this, plus 2025 divided by 5 cube plus 2025 divided by 5 to the power 4. So we know that we got this value, we got this value, we got this, we got this. But here, this onwards, it will all be 0. So essentially what we are doing in this question is we are only calculating these 4. And this came out to be 505. Hope you liked this video.